definition for atom, element, and the molecule. We can move on to compound. We can move on to compound. Simply two or more elements chemically combined. In our other sections, I'm going to define or explain this to you. Chemically, not because of the chemicals that you see, but chemically in chemistry or integrated science, as in the opposite of physical. Hardly will you hear a scientist believing in spiritual things. So we know that if the thing is not physical, then ideally it's supposed to be spiritual. But here in science or chemistry, chemically is the opposite to physical. So if the thing is not physical, something that you can see, then it is what? Chemical. You cannot see, it's hidden. So as we move on, I'll treat a lesson on this. Good. So this is the definition for compound. Two or more elements chemically combined. I think I'll do justice to this topic by adding mixture. Mixture, the definition of mixture. The same format. Two or more elements. Watch out here. Physically combined. Physically combined. These are terms you need to understand. These are terms you need to be able to take before you sit for WASI. So look at it. Two or more elements physically combined. Now, this topic revolves around atom. So I think we should look at one extension of atom, what we refer to as atomicity. Atomicity. Yes, we should look at it. It's not any big word. It simply means the number of atoms found in a compound. So when I say atomicity, I'm talking about number of atoms in a compound. Don't forget that it's not only a compound, it could be a molecule, it could be a mixture. So when we say atomicity, it's the number of atoms in a compound. So I have this compound, ammonia. We can see that ammonia comprises of one nitrogen, hydrogens, how many? Three. So I can say that the atomicity of ammonia is 4. The atomicity of ammonia is 4. We can look at water. Water contains 2 hydrogen atoms and oxygen. So the atomicity of water is 3. The atomicity of water is 3. Good. So you need to get this. Once we are describing this atomicity, it comes with words. Some nice words we need to look at. I hope you remember this. Mono, di, and tri. I hope you remember them. That's the Latin way of counting 1, 2, 3. The Latin, we have mono, di, tri, tetra, penta, hexa, hepta. Good. So when I give you a compound, or I give you an entity like Na, how many atoms are there? 1. So you can describe Na as monoatomic. If I give you H2, Then of course the description is di. Di means two. Diatomic. Don't forget these things. See in the WASI past questions, they're asking them to define diatomic is simply a compound or an entity that contains two atoms. Diatomic. You don't need to memorize this. Monoatomic. Mono means one. One, so a compound that contains one atom. Then tri. I can give you an example. Like CO2. A common CO2. Carbon dioxide that we breathe in. One carbon atom, two oxygen atoms. So that is a triatomic. That is a triatomic that I want you to note. There are more extensions to atoms. This part of the syllabus is purely chemistry. And chemistry deals with elements. So what we are going to do now is to look at the elements and then look at how we will represent the atoms in an element. Because when we look at the structure of an atom, the structure of an atom, that's obvious. This is in the JHS syllabus. We know that atoms are spherical, and then we know that atoms have nucleus. They have nucleus. Check the spelling. This is science. Your spellings must be correct. So N-U-C-L-E-U-S, nucleus. And then we know that in the nucleus we have P. P for protons. And then we have N. N for neutron. Check the spelling. I've marked a lot of scripts and you see students finding it difficult to write this. Neutron. It's like neutral. And then this shell contains electrons. Electrons. This is the structure of an atom. If you want to have a picture of an atom, this is the typical structure of an atom. So you can draw the structure of an atom for hydrogen, for sodium, for all the elements that you can find in the periodic table. But science makes it simple. Science makes it simple. They actually call it, or chemistry will call it, representation of the atom. How to represent the atom. How to represent the atom. We cannot continue to draw the atomic structure for all the elements. So we try to look for another way to represent the atoms. The first thing we need to look at is the symbol for the element. Symbol. So the element that I like most is sodium. S-O-D-I-U-M. I like this element very well. Its original name is nallium. But the modern name is sodium. So nallium, Na. That is why the symbol for sodium is Na. It is coined from its original name, nallium. Now when I take sodium, this is the symbol, sodium. The next thing I need to look at is, because previously we looked at the structure of an atom, we realized that atoms contain electrons, atoms contain protons, and atoms contain neutrons. So I'll put a number here, the left lower subscript, and then put a number here, the left upper subscript. Now I want you to observe this very well. What this means is that X is the number of protons. The number of protons of sodium. That's the element. X is the number of protons. X is the number of protons. There's a nice name for that number of protons. If you can't write number of protons, Then you can say atomic number. That is also accepted. We will use it a lot. Atomic number. And then Y. Y is protons plus neutrons. Remember where we saw protons and neutrons? In the nucleus of the atom. So when you put them together, you form Y. So anytime you see that an element or an atom has been represented and then they've written any number at the left top top or superscript, what it means is protons plus neutrons. There's a nice name for it. We'll say number.